All right, Chapter 9 review. Now we're working on Section 9.5. We're going to be doing page 507 in this lesson. So here we go. Number 1 says this. The focal length F of a camera is 2 inches. So we know F is 2 inches. The equation for a lens is this. 1 over F is equal to 1 over DI plus 1 over DO, where DI is the distance between the lens and the film, and DO is the distance between the lens and the object. Alright, so here's what we know. Question 1 says this: the object is 10 feet away. So the object is 10 feet away. How far should the lens be from the film? So the object is 10 feet away, so that tells me DO is 10. Alright. And it's asking me what DI should be. What should the distance be from the film from the lens from the film? So there's my question mark. So let's just plug it in and let's go. So everything's already given to me. So 1 over F would be 1 over 2. That's in inches now. This matters. Equals 1 over DI equals, sorry, plus, I lied to you there, plus 1 over DO. But let's put DO in inches. So if it's 10 feet, how many inches would that be? 10 times 12, right? 120 inches. 120 inches. Alright, so all we've got to do now is find our LCD. If we multiply everything by 120 DI, we'll be able to figure this out. So the first term becomes 60 DI equals 120 plus DI. Subtract DI each side, so we get 59 DI equals 120. So DI is just going to be 120 over 59 inches. So divide, and you can put that in your calculator if you want. So that'll be 120 divided by 59. And that gives us 2.033. So the distance would be 2.033 inches. Alright. Number 2. It's going to use some of the same information up above. So number 2 tells us this. The object is 20 feet away. How far should the lens be from the film now? Okay, so F still equals 2 inches. DO equals 20 feet, which is going to be, what, 240 inches? Again, make sure everything's in the same unit of measure. The equation they give us is 1 over F equals 1 over DI plus 1 over DO. So that's just plug and chug. 1 over 2 equals 1 over DI, which is our unknown, plus 1 over 240. Okay, what's the least common denominator? 240 DF, or sorry, 240 DI. So it's going to be 120 DI equals 240 plus DI. So what are you starting to recognize here? It comes to a point where it's always going to be what? Basically 2 inches. So subtract DI at each side, so you get 119 DI equals 240. Get your handy dandy calculator out. You can put 240 divided by 119, and you're going to get 2.01. So DI is going to be 2.01 inches. Okay? Okay, so di equals 2.01. And what you notice, as the distance of the object gets farther and farther and farther, your distance from your lens to your film, your di value is going to be closer to 2. All right, so going to number 14. So it says simplify each sum. So I got negative 3x over x squared minus 9 plus 4 over 2x minus 6. Okay, let's simplify, or let's factor these terms, and let's kind of simplify them. So I got negative 3x over a difference of squares, so that's going to be x minus 3 times x plus 3, plus 4, and then the denominator here, what's the GCF? 2, so I can make it x minus 3. So now we got to simplify it, so we got to sum like terms. So we got to get the denominators to be the same. So what's the LCD? Well, it'd be 2 times x minus 3 times x plus 3. So what do I need to multiply the left side by, top and bottom by, to get the same three terms? Well, I need to multiply the top and bottom by 2 over 2. What about the right side? What do I need to multiply the right side by? X plus 3. Okay, now my denominators are all the same. So now I can add like terms. So the left side is going to be 2 times negative 3x, which simplifies to negative 6x over 4 times x plus 12, or sorry, 4 plus x plus 3, so that would be 4x plus 12. And all that's over the denominator. We'll fix that in just a second. So let's sum like terms. So I'm going to get negative 2x plus 12 over 2 times x minus 3 x plus 3. Can I simplify it a little bit more? Absolutely. What can I factor out up top? Well, I could factor out a 2 if I wanted to. I could factor out a negative 2 if I wanted to. So let's factor out a negative 2. So I'm going to get x minus 6 up top over 2 times x minus 3 x plus 3. 2's cancel, the negative sign stays. Okay, so I get a negative 1 x minus 6 over x minus 3 x plus 3. That's a good solution. That works. You could also factor a negative 1 back in, and you get 6 minus x over top over x minus 3 x plus 3. Either of those are good. I'll accept either. Okay, next problem. Number 21, still on page 507. 2x over x squared minus x minus 2 minus 4x over x squared minus 3x plus 2. Let's look at the first denominator. If you need x factors, you can. We'll do a little bit of work over here on the right. So I got x squared minus x minus 2. Let's x factor that. My a times c value is negative 2. My b value is negative 1. Two numbers, product negative 2, sum negative 1. Well, that'd be negative 2 and positive 1. So the bottom over here would be x minus 2 times x plus 1. Let's look at the right side. Minus 4x. And I'm going to show you something I'm going to do with that in just a second. Over, if you need to do this one, x squared minus 3x plus 2. Two numbers that give me a product of 2 and a sum of negative 3. That'd be negative 2 and negative 1. So x minus 2 times x minus 1. Okay. Now, I told you I was going to show you something. I don't like subtracting this way. Since there's only one term on top, I can say plus. I can change that sign to a plus and make that a negative. Now it's going to be a little easier to distribute. So let's look. What's the GC, or what's the LCD? What's the least common denominator? I have a x minus 2 here and here. And I have an x plus 1 and an x minus 1. So what do I need to multiply the left side by to get it all to be the same on the bottom? X minus 1. What do I need to multiply the right side by to get it all the same on the bottom? X plus 1. And again, the rules of algebra of equality stay true. If I multiply something on the bottom of the denominator, I can multiply anything I want as long as I do it on top and bottom. All right, the denominators are now the same. So let's go ahead and distribute. So 2x times x is 2x squared. 2x times negative 1 is negative 2x plus, now we're going to distribute the negative 4. Negative 4x times x is negative 4x squared. Negative 4x times 1 is negative 4x. All that's over the denominator. Okay, so let's sum like terms. So I'm going to get negative 2x squared minus 6x. Okay, all over the denominator. We can still factor out a negative 2x. When we do that, what am I left with? X plus 3. Okay, so now all that is going to be over x plus 1 times x minus 1 times x minus 2. There's nothing more I can do. There's nothing more I can simplify. It didn't say state the restrictions or anything like that, so there we go. Negative 2x times x plus 3 over x plus 1 times x minus 1 times x minus 2. Okay. Next problem. Number 28. Complex fractions. 2 over x plus y all over 5 times x plus y. Okay, easy terms. We're going to multiply the top and bottom by the reciprocal of the denominator, which is x plus y over 5, x plus y over 5. The bottom cancels, the x plus y's cancel, so for 28 the answer is just 2 over 5. Okay, 29. 3 over x minus 4 all over 1 minus 2 over x minus 4. Okay, what can I multiply everything by, top and bottom, to get rid of all the denominators? Well, if I multiply this whole thing by x minus 4 over x minus 4, I'm going to get rid of the denominators. So the top's just going to become 3. The bottom, we got to distribute the x minus 4 times both terms, so it's going to be x minus 4 minus 2. So I can rewrite this as 3 over x minus 6. That's our answer. All right, going to 48 now. 48. I got 2 over x plus 4 plus 2 all over, and again I like to make that a little bit darker, 1 plus 3 over x plus 4. It's real similar to the one we just did. What can we multiply everything by, top and bottom, to get rid of the denominators? X plus 4 over x plus 4. So what's going to happen? So I'm going to leave a little space here. So when we multiply x plus 4 to the first term, we're just going to get 2. The second term, we're going to get 2 times, and I'll leave it in factored form for now, 2 times x plus 4. On the denominator, I'm going to get x plus 4 plus 3. So now on top, let's go ahead and distribute that. So it's going to be 2 plus 2x plus 8, just distributed the 2, over x plus 7. Okay, let's sum like terms real quick. So I got 2x plus 10 over x plus 7. I can go ahead and factor it out if you want to. It's not going to really help the cause, but 2 times x plus 5 over x plus 7. I would accept either of these answers for number 48. All right, 49. X, or sorry, 3 over x minus 2 minus 5 all over 2 minus 4 over x minus 2. Same concept. I'm going to multiply everything by x minus 2, top and bottom. So when we do that, first term on the numerator just becomes 3. The second term is minus 5 times x minus 2, so we're going to have to distribute the negative sign at top, over 2 times x minus 2 minus, the x minus 2's are going to cancel, 4. So it's going to be 3 minus 5x plus 10, which is going to be negative 5x plus 13. The bottom is going to be 2x minus 4 minus 4. So that's going to be 2x minus 8. If you want to factor out the 2 on the bottom, you can. So it's going to be negative 5x plus 13 over 2 times x minus 4. Nothing cancels. All right, last one on this section. All right, number 53. A word problem. Let's read it. If you jog 12 miles at an average rate of 4 miles an hour and walk the same route back at the average rate of 3 miles an hour, you'll travel 24 miles in 7 hours and you have a rate of 24 over 7. What is your rate if you travel d miles at 3 miles an hour and d miles at 4 miles an hour? So this is a distance rate problem. Distance equals rate times time. Okay, so let's just column this up. So when I jog 12 miles, I have a rate of 4 miles an hour. When I walk 12 miles, I have a rate of 3 miles an hour. Okay, so how much time did it take me? 3 hours to go 12 miles with a jog and 4 hours to go 12 miles with a walk. So to find my average rate, 12 plus 12 is 24. 3 plus 7, or 3 plus 4 is 7. So my rate is unknown. Okay. So to find my rate for the top problem, R is just going to be 24 over 7. Okay. Because you can add your time and you can add your distance. The rates you can't add that way. So for the first problem, it tells us the rate's 24 over 7. So let's go through now. It tells me in distance, rate, and time. I go distance d at a rate of 4 miles an hour. I go back at a distance d 3 miles an hour. How do I find my new rate? Question mark right there, right? So let's find out the time. The time to go this distance was d over 4. And the time to go this distance was d over 3. The total distance we traversed was 2d. So we can say 2d equals the rate times d over 4 plus d over 3. So we just got to solve for the rate. So let's work on the problem. Let's get the time to be one fraction. So what would I multiply? So we're going to rewrite it over here so you can see. So I got 2d equals the rate times d plus 4 plus d plus 3. So what could I multiply those fractions by to get them to be the same denominator? If I multiplied the first one by 3 over 3 and the second one by 4 over 4, I'm going to have a denominator of 12. So it's going to be 2d equals r times 3d plus 4d all over 12. So I could rewrite that as 2d equals r times 7d over 12. Okay, so now I have to solve for r. Multiply each side by the reciprocal. 12 over 7d. 12 over 7d. Okay, the 12s cancel, the 7d's cancel. So now I'm going to get 24d over 7d equals r. R is going to equal 24 over 7. Okay, now that was kind of a trick question. We really didn't have to do all that work. Here's the deal. If the distance was the same going each direction, which it was 12 and 12 in the first example, d and d in the second example, and the rates were the same for each equal distance, the overall rate's going to be the same. It doesn't matter the distance traversed. The rate's going to be the same. So in this example, the rate will always be 24 over 7. But hopefully you kind of see how we took the steps to solve that. Okay? All right. That is it for this section.